Curve sketching part 2. Let's continue with curve sketching. I will show you 2 more examples in here. Example. Use the guidelines for graphing to sketch the graph of f of x equal quantity x squared minus 4 to the 2/3 power. So what was the first step? The first step was to find the domain. If I rewrite this function, this is equal to cube root of quantity x squared minus 4 to the 2nd power. Because this radical function is cube root and index is odd, domain is all real numbers, which is from negative infinity to positive infinity. Second step was to find all the intercepts. Let's find the y-intercept. Y-intercept can be found by plug in 0 for x. And when you do, y is equal to cube root of 0 squared minus 4 to the 2nd power, which is equal to cube root of 16. Cube root of 16 is same thing as 16 to the 1/3 power. And when you use calculator, it's about 2.5. And that's for your graphing purpose where the point is, since it's not exact number. Now let's find x-intercept. X-intercept can be found by plug in 0 for y. And y is f of x. So then that's 0 equal quantity x squared minus 4 to the 2/3 power. And this quantity x squared minus 4 to the 2/3 power is 0 if the quantity x squared minus 4 is 0. And this quantity x squared minus 4 is 0 when x squared equal 4. We can now use square root property and we can find that x is equal plus or minus 2. So my x-intercepts are 2, 0, and I have another one, negative 2, 0. Third step, find all asymptotes. How about vertical asymptotes? Well, this function is defined on all real numbers. So there is no vertical asymptotes. How about horizontal asymptotes? What is the degree of numerator? Look at the highest power of a numerator. It is x squared to the 2/3 power, which is x to the 4/3 power. And my degree of denominator is 0, since I don't have any variable in the denominator. And because degree of numerator is not less than or equal to degree of denominator, I don't have any horizontal asymptotes either. And my degree of numerator 4/3 is not exactly 1 degree higher than degree 0. So therefore, there is no slant asymptotes. So I do not have any asymptotes for this function. Next step, find all extremas. So let's find the f prime of x. What is f prime of x? So take the derivative of this one. You take the derivative, 2/3 power comes down to the front, inner function raised to the lose 1 power from 2/3 power, you get negative 1/3 power times chain rule multiplied by derivative of inner function, which is 2x. Now multiply numerators, which is 2 times 2x, so that is 4x. 3 is in the denominator, and my negative exponent, I can bring it down to the denominator, and it turns into a positive exponent. So this is my derivative. And my f prime is ever 0 if numerator is 0. And numerator is 0 if x is 0. If x is 0, my numerator is 0, but my denominator is not 0. So therefore 0 is critical number. When does my f prime not exist? My f prime does not exist if f prime does not exist if denominator is 0. And denominator is 0 if this quantity is 0. And you know your quantity is 0 if x is equal to plus or minus 2. And f of plus minus 2 exists. So x equal plus minus 2 is also critical numbers. So I have 3 critical numbers. So let's locate 3 critical numbers. I have a critical numbers, one of them 0, one of them -2, one of them +2. Pick a test point in each interval. I'm gonna pick -4. Between -2 to 0, I will pick -1. Between 0 to 2, I will pick 1. After 2, let me choose 4. And then let's plug it into our f prime to test the sign. So if you plug -4 in every x you see, 4 times -4 is negative, 3 is a positive, and positive number doesn't affect your sign for the whole quotient. So let's just plug it in here. And -4, if you square it, it is 16. Minus 4 is a positive number. And cube root of a positive number is positive. So this whole quotient becomes negative. So this interval will be negative, which means your graph is decreasing. Now let's test -1. 4 times -1 is negative. 3 doesn't affect anything, and -1 square is positive 1. Positive 1 minus 4 is -3. Cube root of negative number is negative number. So therefore, this is negative over negative, which is positive. So second interval is positive, which means graph will be increasing. So there will be relative minimum since the graph goes down, and then it's gonna come back up. So at x equal -2, we have relative minimum. Now, how about test point 1? 4 times positive 1 is a positive over 3 times. 3 doesn't do anything. 1 square is 1. 1 minus 4 is negative number. And again, cube root of negative number is negative. So this quotient is now negative, which means graph is now decreasing. And because graph went up and then came down, there is a hill there. So at x equals 0, you are going to have relative maximum there. Last test point, when x equals 4, 4 times 4 is positive. 4 square is 16. 16 minus 4 is positive number. Cube root of a positive number is positive. So therefore, whole quotient is positive. So graph goes back up again, and you're going to have another relative minimum here. So what is relative minimum? Relative minimum occurs when x equals -2 and x equals +2. But we already found out those 2 points on the graph. When x equals 2 or -2, y coordinate was 0, and that was our x-intercept of our graph. So my relative min is -2, 0. Another relative minimum is 2, 0. What about relative max? Relative max occurs when x equals 0. But that point would be the y-intercept, and we already got the y-intercept as well. And y-intercept was 0, cube root of 16. So that will be our relative maximum. Now let's find the f double prime of x, and we can find the points of inflections, and also find the intervals of concave up and concave down. So number 5, our f double prime of x equals we're going to take the derivative of f prime of x, and we're going to use a quotient rule. So low 3 times quantity x squared minus 4 to the 1/3 power times d high, derivative of high is 4, minus high is 4x, d low, take the derivative of low. So 1/3 power comes to the front, and it is 3 times quantity x squared minus 4 to the negative 2/3 power times chain rule, derivative of inner function is 2x over square below. So we're gonna square the whole denominator, and my denominator was product 3 times the quantity x squared minus 4 to the 1/3 power. So we're gonna square this whole thing, which is equal to, let's simplify a little bit so we can see better. So 3 times 4, I have a 12 quantity x squared minus 4 to the 1/3 power. On the second term, I can cancel the 1/3 and 3, since 1/3 times 3 is 1. And negative 4x times 2x is negative 8x squared. And you still have a factor x squared minus 4 raised to the negative 2/3 power over. Now we're gonna square each of the product in the bottom. And 3 squared is 9 times, if you raise quantity x squared minus 4 to the 1/3 power to the second power, you get quantity x squared minus 4 to the 2/3 power. Let's factor out the common factor. On the numerator, common factor of 12 and 8 is 4. And we do have also common factor of x squared minus 4. So we are going to factor out the quantity x squared minus 4 to the lower power of the 2, which is negative 2/3 power. Then 4 times 3 is 12. Quantity x squared minus 4 to the negative 2/3 power times the quantity x squared minus 4 to the positive 4th power. When you add the exponent, it gives you back 1/3 power. Minus 4 times 2x squared gives you negative 8x squared, and your whole quantity x squared minus 4 to the negative 2/3 power is out, so we close bracket there. Over 9 times quantity x squared minus 4 to the 2/3 power. Simplify one more time. On the numerator, you have 4 times. Now, distribute inside of a bracket, you get 3x squared minus 2x squared gives you positive x squared. 3 times negative 4 gives you negative 12. And you had a 9 in the denominator, and you had originally x squared minus 4 to the 2/3 power, and you have another x squared minus 4 to the negative 2/3 power comes down. So then, since they have the same base, you can add exponent, and they become x squared minus 4 to the 4/3 power. And here is our f double prime. So then our f double prime is 0 when numerator is 0. And my numerator is 0 and denominator is not 0 if x squared is 12. X squared is 12 if x equal plus minus square root of 12, which is equal to plus minus 2 radical 3. So x equal plus minus 2 radical 3 are possible inflection points. Now, when is my f double prime undefined? My f double prime does not exist if x squared minus 4 was 0. X squared minus 4 is 0 if x equal plus minus 2. Remember, our original function was defined on all real numbers. Therefore, these two are also possible inflection points. And these possible inflection points are really the inflection points if f double prime sign changes before and after these possible inflection points. So let's locate these numbers now. By the way, x equal plus minus 2 radical 3 is about plus minus 3.5. Let's go back to our sine graph. So my possible inflection points are -2 and a +2 and -2 rad 3 and 2 rad 3. We need to now pick a test point. My test point's gonna be out here. Any number less than -2 rad 3, I'm gonna pick -5. Test point between -2 rad 3 and -2 will be -3. I will choose 0 for test point between -2 to 2. I'm gonna pick 3 for the test point between 2 and 2 radical 3. Let me choose 5 for test point after 2 radical 3. And you can plug it in right here to test the sign. Let me plug -5 here. Then what I'm gonna get is 4 is a positive number, and positive number, I told you, does not affect the sign of this quotient. So plug it into x squared minus 12. -5 squared is 25 minus 12 is positive, over 25 minus 4 is 21, and cube root of a positive number is positive. So this quotient is positive. So f double prime sign in this interval is positive. But they're gonna give you same sign, whether you plug a +5 or -5, since we're gonna square it. So this interval out here will be also positive. Now let's test -3. -3 squared is 9. 9 minus 12 is negative. 9 minus 4 is positive, and cube root of a positive number is positive. And this whole quotient is then negative. So this interval is negative, and again, whether you square the -3 and +3, they're gonna give you same sign. So this interval is gonna be negative also then. And now, lastly, let's test 0. 0 squared minus 12 is negative, over 0 squared minus 4 is negative number, but cube root of negative number to the fourth power is going to be positive. So this quotient is negative. So then -2 radical 3 gives you POI, point of inflection, because there is a sign change before and after the -2 radical 3. -2 and +2 are not inflection points because there is no sign change before and after the ±2. However, 2 radical 2 is also point of inflection because before and after the 2 radical 3, there is sign changes of f double prime. So let's find the points of inflection. So what is the f of -2 radical 3 is equal to? I need to go back to original function, and original function was quantity -2 radical 3 square minus 4 to the 2/3 power, which is equal to, when you square the -2 radical 3, that's a 4 times 3 is 12. 12 minus 4 is 8, is 8 to the 2/3 power. 8 is 2 cubed to the 2/3 power. 3 cancel. I get 2 square, which is 4. And my function too, whether I square the -2 radical 3 or +2 radical 3, I'm gonna get the same y value. So my points of inflections are -2 radical 3, 4, and positive 2 radical 3 comma 4. And let's combine f prime and f double prime to look at the shape of our graph. If we look at from negative infinity to negative 2 radical 3, my graph goes down, but it is concave up. So it's gonna be cup shape that is decreasing. So you're gonna get like that. But then negative 2 radical 3 gives you point of inflection. So concavity change it to negative, which means concave down. Concave down is umbrella shape. And graph is still decreasing up to negative 2. So you're going to get a graph like that. And from negative 2 to 0, graph is increasing now, but concavity is still negative. So it is still umbrella shape. However, your graph is increasing. And then from 0 to 2, f prime is negative, meaning graph is decreasing, and concavity is still negative. So it's still umbrella shape, and it's gonna go down. And then from 2 to 2 radical 3, f prime is positive, so graph is increasing, but concavity is negative. So it's a concave down. So it's an umbrella shape that is increasing. And then at 2 radical 3, concavity changes. And now concavity is up, which is a cup shape, and it is still increasing. So you get graph like this. And you do get relative minimum here, relative minimum here, and relative max here. And this is POI, and this is POI. All right, so let's put all that information together to graph our function. Our y-intercept is 0, 2.5. We don't have any asymptotes. Our minimum was negative 2, 0 and 2, 0. Our maximum is my y-intercept. My point of inflection is negative 2 radical 3. It was about negative 3.5, 4. And another one is 3.5, 4. So then look at our shape of a graph. I have a decreasing graph that is concave up, and then concavity changes from point of inflection, and it's gonna decreasing and an umbrella shape. And then from my minimum to another minimum, I have an umbrella that is increasing and then decreasing. And then another minimum 2, 0 to inflection point, I have increasing graph that is concave down. And then from point of inflection to infinity, I get increasing that is concave up. So here is my graph. Last example. Use the guidelines for graphing to sketch the graph of f of x equal x to the fourth power minus 6x to the second power. This is regular polynomial, so of course the domain is all real numbers. Let's find the intercepts. We can find y-intercept by setting x equals 0. When x is 0, 0 to the fourth power minus 6 times 0 to the second power is 0 minus 0, which is 0. So my y-intercept is 0, 0. How about x-intercept? We can find x-intercept by setting y equals 0. So 0 equal x to the fourth power minus 6x squared. 0 equal, we can factor out x squared minus 6. So this product is 0 if x equals 0 or x squared equals 6, which gives me x equal plus minus square root of 6. So I do have 3 x-intercepts, which is 0, 0, radical 6 comma 0, and negative radical 6 comma 0. So these are my 3 x-intercepts. We have no asymptotes since this function is defined on all real numbers. Degree of numerator is not less than degree of denominator, and degree of numerator is not exactly 1 degree higher than the degree of the denominator. So there are no asymptotes. Let's find extremas. My f prime of x equal 4x cubed minus 12x. And common factor is 4x. When you factor it out, you get x squared minus 3. And this f prime is 0 if x equals 0. And also x equal plus minus radical 3. And this f prime is never undefined, so does not exist, never happens. So I do have 3 critical numbers, 0 and plus minus 3. And radical 3 is about 1.7. So let's locate my 3 critical numbers on the sign graph. Here's 0, and here's about 1.7, let's say, radical 3, and negative radical 3. So my test point is gonna be negative 4 for any number less than negative radical 3. And between negative radical 3 and 0, I'm gonna choose negative 1. And between 0 and radical 3, let me choose 1. Let me choose positive 4 for any number greater than radical 3. And I'm gonna test my test points here. So when I plug negative 4, it is negative times negative 4 squared minus 3 is positive, and negative times positive is negative. So my first interval is negative. So my graph goes down, decreasing. When you test negative 1, 4 times negative 1 is negative. Negative 1 squared minus 3 is negative. And negative times negative is positive. So my second interval is positive. And when you plug positive 1, 4 times 1 is positive. 1 squared minus 3 is negative. So again, I get negative. When you plug 4 in there, 4 times 4 is positive. 4 squared minus 3 is positive. So again, I get positive. So my graph goes down and up and down and up. So I have a relative min here, and I have a relative max there, and I have a relative min there again. Let's find those relative extrema. F of negative radical 3 is, go back to original function, negative radical 3 to the 4th power minus 6 times negative radical 3 square is equal to 9 minus 18, which is negative 9. But whether you plug negative radical 3 or positive radical 3, you can see I'm gonna get the same answer since we're gonna raise to the power 4 and a power 2. So this is going to be also negative 9. So my relative min is negative radical 3 comma negative 9 and radical 3 comma negative 9. And my relative max is f of 0. F of 0 is 0 to the 4 minus 6 times 0 to the second, which is 0. So my relative maximum is 0, 0. Last step is to find the points of inflection at intervals of concave up and concave down. So let's find second derivative. So fifth step, f of double prime of x is equal to, I'm going to use this polynomial form of f prime of x. So when I take the derivative of that, I get 12x squared minus 12. And when I factor out 12, I get x squared minus 1. And this factors as x plus 1 and x minus 1. So I know my f double prime is 0 when x is equal plus or minus 1. And because this is polynomial, this is always defined and does not exist, does not happen. So my possible points of inflection is plus or minus 1. So let's locate them. -1 and +1. And then let's pick a test point for signs of f double prime for each interval. So I'm going to pick -3 for the interval less than -1. And I'm going to choose 0 for interval between -1 and 1. And let me choose 3 for the interval greater than 1. So then, okay, so when you test -3, I get 12 times -3 plus 1 is negative. -3 minus 1 is negative. So when you multiply two negatives, I get positive, which is concave up. And then when you test 0, 0 plus 1 is positive. 0 minus 1 is negative. So that I get negative on the interval between -1 and 1, which is concave down. And when I test 3, 3 plus 1 is positive, 3 minus 1 is positive, and positive times positive is positive. So third interval is positive, which is again concave up. So I do get 2 points of inflections since there is a sign change before and after the -1, and there is also sign changes and before and after the +1 as well. So -1 and +1 is the point of inflection, and let's get them. And if you recall, original function is x to the fourth power minus 6 times x to the second power. So whether I plug -1 or +1, I'm gonna get the same y coordinates. So let me calculate one and use for the other as well. F of 1 is equal to 1 to the fourth power minus 6 times 1 to the second power, which is 1 minus 6, and it is -5. Therefore, my points of inflections are -1, -5, and +1, -5. And let's put all this information together to graph our function. Y-intercept was 0, 0. My x-intercept is also 0, 0. Radical 6 is about 2.44. So 2.44, comma 0, and -2.44, comma 0. I have no asymptotes, and my relative minimum is negative rad 3, comma -9, and negative rad 3 was about -1.7, comma -9. Let's say this is -2, -4, -6, -8. So -1.7, comma -9, and 1.7, comma -9. And this is my minimum, and this is my another minimum. 0, 0 was my maximum. Now, my graph is decreasing from -infinity to negative radical 3, but it is concave up. So this should be cup shape. but cup shape goes up to -1 since I have a point of inflection at -1, -5. So -1, -5 is a point of inflection, meaning my concavity changes. So from the negative infinity to my minimum, my graph is going down, but it is cup shape. And cup shape continue up to inflection point. But from negative radical 3 to -1, it is still concave up. I'm going to get a graph like this. And now -1 to 0, f prime is still positive, meaning graph is still increasing, but your concavity from -1 to 1 was negative. So it's concave down now. So I gotta have umbrella shape. So graph will be umbrella shape here. And then from 0 to another inflection point, your inflection point is 1, -5. Your concavity is still negative. F prime is negative. So graph is decreasing, but it's concave down. So it's umbrella shape. Now, because this is a point of inflection, concavity changes to positive from 1 to infinity. So I'm going to have a cup shape from 1 to infinity, and it will be decreasing from 1 to radical 3, and then increasing from radical 3 to infinity. And your graph will look like that. It seems very lengthy. That's because I'm doing this and at the same time I'm explaining every single step. So each of these problems should take you about 15 minutes when you do it alone, I would say. And definitely one of them's gonna be on the test. So make sure you know how to do the curve sketching.